乐可俊先生，他将为我们介绍面向自制网络的 Telecom OS。有请。
Hello, ladies and gentlemen. I'm Jackson Le from the Ericsson. I'm very glad to represent Ericsson to share our recent practice in autonomous network areas. Today, my topic is to build a telecom OS for the autonomous network. And with the boost of the ChatGPT, as the previous speaker mentioned, and the global large language models boost up from the last year, the wave of the AI is pushing from concept to maturity and integrated with various industries. The AI is really seeing tremendous in power value and showing great development potential, particularly in the areas like natural language processing, the healthcare, auto driving, and make the AI as the center of attention. Now we back to our telecom industry. What are the developer and application prospects when the AI combined with telecom? We say the telecom industry must transform. Why must it transform? In the recent decade, we can see the telecom technology evolved faster from the 2G to 5G. The network scalability increased very quickly, and the network structure become more and more complex. Also, the network vary variously services. At the same time, the application of the telecom technology have embedded in various industries. The people become more and more rely on the service carried by the telecom network. As this result, the growth demand for the high quality and the more differential service for the telecom network is more important. Both the involvement of the telecom network itself and the changing demand of the end user are significantly challenging the telecom network the operation models. In traditional telecom network management model, primarily rely on the manual process. They can't meet the requirement of the new environment. So a new self-intelligent network operation model has become the only choice. That's the new model bring the new challenge, and the new challenge is the driving force for the self-intelligent network operation models. In 2019, the TM Forum has released the autonomous network concept. A lot of discussion and research has been in these areas. Almost all the operators has dedicated enhancing the automation of network operation and achieved good result in the terms of the procedural automation execution. But in the analysis and make a decision for the network issues, they also heavily relies on the human experience. You know, the human experience people for the telecom management is limited. The limited resource cannot support the fast scalability growth the network and the new change very quickly the new service model and the user experience requirement. So this limitation become the challenge to the further development of the self-intelligent network operation. So to liberate the human resource as much as possible from the daily task, such as the telecom network, they are planning, the designing, build, maintenance, operation, etc. It's mandatory to liberate the human resource. So we can see the AI as a key technology that has been attended by the major operator and equipment vendors, where the AI will be the profound impact of the entire the telecom industry. The AI will play an assistant and argument role and effectively enhancing the automation analysis and the decision making in network operation and take the majority routine job judgment and decision. Only by fully leveraging AI technology, we can further advance the development of the self-intelligent network operations. And Ericsson, we can see what Ericsson has done in these areas. As the world leading telecom equipment supplier, Ericsson always keep a focus on the innovation of the AI technology in the network operation areas. Ericsson has put efforts in deeper study and practical different use cases to accelerate autonomous network towards success. Ericsson also embedded AI technology in various aspects to meet different time-sensitive closed-loop use case requirements. At this picture, we can see the Ericsson intelligent network operation capability. We have the intelligent AI library. This library includes a range of the AI models focusing in the telecom operation areas. For example, we can see the first one, we have the cell issue classification model. For this model, there can be automatically identified the cell performance issue in the massive data. Next, we can see we have the uplink interference classification model. They can be to identify the environment interference, to identify the interference type and what's the source from there. The third, we have the root cause, we have the cell issue forecast model. This model can forecast the cell traffic based on the as is and the history data to forecast the future, the volume, the data. And we have the root cause analysis identification module. This module is to analyze and detect in deep analysis the potential problem reason. Also, we have the optimized recommender model. This model can recommend the suitable solution based on the root cause. They recommend the suitable solution to fix the network issues. So, with this intelligent model, their flexibility can combination to support various network operation tasks, such as the design, such as the maintenance, optimization. Then they can support to enhance our network operation automation level. Yeah, we can see what our target is in 2015 to reach level 4. This is the support from the Asia to support this level up. Yeah. Next, we must say the practice is the key to verify the maturity of the technical solution and push it continuously moving. In recent years, Ericsson has actively in development and create AI solutions through the collaboration with China mainland operators and has achieved many successful cases. Here, I want to share the 4 typical cases. Yeah. This is the first one. The first one is the smart performance diagnosis case. For this case, is a solution for efficiently detect abnormal cell in a large scale and complex radio network. Based on the massive data collection from the radio network, the smart performance diagnosis has built 3 AI models. The first is the issue classification layer. In this layer, we can quickly and accurately detect and locate the cell abnormals in the network. The second layer we call the multi-dimension analysis layer. Then, in this layer, the issues can be cataloged in multi-dimension and to provide the probability of why the problem occurring. And after we found the problem occurring, the root cause, we can use the solution and the recommendation execution model. For this model, we are auto-generating the solve suggestion and auto-load there to the network system to fix that. So, with the help of this AI analysis and decision models, the network engineer, they worked for the the radio network performance diagnosis lead time can reduce from 20 minutes to less than 5 minutes. Ericsson integrated this solution in the daily maintenance and optimizing work can comprehensively improve the capability and efficiency of this work. This is the first. The next case is the network auto hearing. This solution is to improve the network robust. In the traditional telecom network, node outage, we handle the node outage. The process is required to first analyze the alarm, then dispatch the working order, then to replace the fault units. Normally need at least 1 hour to fix the traffic. And during this period, the loophole will impact the end user perspectives in these fault areas. So for the network auto hearing solution, the system will continuously monitor the network events and use AI to determine whether it is the outage happen. If the AI model confirm this outage happen, they will automatically to generate an emergency adjust plan based on the surrounding nodes. We can see communication network, not only nodes, there are surrounding nodes there. They can adjust the plan will, according to surrounding nodes, their network information, such as their environment, their traffic load, and their as-is capability. And then the system will auto-implement the emergency plan, and the surrounding node will automatically change their parameter. Then the traffic will be taken over by you can see the right picture, the traffic can be taken over by the surrounding node. By this process, the traffic stop time can reduce from 1 hour to less than 5 minutes. And the user throughput compression rate can be over 15%. That will strongly help to secure the end user experience and satisfaction when the network have the outage here. The third one is the network coverage automation solution. Then the background is with the network, mobile network evolution and continuous construction. The network structure become more and more complex, and the traffic volume, tight frequency also happen everywhere. For example, in the working hour, the traffic in the office area, but in the after working hour, they are in the home area. How to handle that? Yeah, so to achieve the coverage optimization and adjusting integration and efficiently, so Ericsson provided this. We provided this solution, and this solution will use the AI model to analyze all the network data, and will automatically give the specific solution for the cell coverage issue, or they'll have the tight frequency areas. The output of the AI model will be for some the new the AS radio. They will give the suggested pattern. This is which pattern they write for the high building or for the large scale. And for the traditional antenna, it will give how many the downtime and the parameter you want to set to test the coverage. Yeah. So after we evaluation the benefit with this solution, we say China a setting level. Setting level always have the several thousands of sites. This volume, the coverage optimization workload can reduce them from the 5 week, normally 5 week, to 1 week. This solution can significantly reduce the routine operation workload and shorten the lead time to the business needs. Yeah. This is the third one. The fourth one is the most cared, the power saving. In the 5G network, the high energy consumption is the equipment and put high pressure on the operation expense. Energy saving is always one of the key performance indicators for the 5G network. However, the traditional node, the power saving setting structure is a one-size-fits-all approach. There are few to create to tap out the power saving potentials. And to achieve the intelligent and precise energy saving, Ericsson developed this smart power saving solution. This uses the AI model to automatically generate the energy saving schema for each node according to the network traffic and the performance prediction. They use the prediction model. And then will be support the energy saving in different scenarios. With this smart solution, we can ensure the energy saving will not affect the network performance. There will be better balance the network type, both the network traffic growth and power expense. After evaluate the extra power saving, we see the extra power saving is we have used the system basic functionality. After that, with this smart solution, they can extra get the maximum 27% power consumption expense. Okay, these are the 4 use cases. AI-based solution has been successfully validated and addressed to the China common network operation issues. The Ericsson has more AI-powered practice in globally. Okay. Then the telecom technology evolution is rapidly changing the industry. The wave of the AI is surging ahead. The combination of these two forces holds limited potentials. Looking forward, the network intelligent operation enhanced by the latest AI technology will be an inventable trend in telecom industry. Ericsson leverage AI and continuously evolve the self-intelligent network capability will create a self-intelligent network operation platform. We have this platform to support the evolution of network equipment. This platform will like an operating system for the autonomous network. The platform will integrate the end-to-end capability, automation, and AI to provide essential self-intelligent network applications like the fault auto identify, recovery, network resource scaling, allocation, and auto performance issue diagnose, quality improvement. And also, Ericsson, this platform will provide a common API to explore the intelligence network operation capabilities. The Ericsson, we can provide a closed loop automation, as I just showed the last 4 cases, the closed loop automation case to help our operator to fulfill their fulfill their operation needs. Also, based on this API, we are welcome both operator and the third-party partners to build their cross-domain and multi-vendor application and products, empower the tier-made operation according to the operation to support the specific network operation requirements. So based on this approach, will support and continuously innovation in the self-operation network ecosystem develop. Let's join together to this ecosystem. Thank you.
Thank you, Mr. Ler, for the interesting speech. Network operation and maintenance has always been the basis for service providers provide traditional services as well as any new emerging services. And we also released 9天's first network large model yesterday. So it will be very interesting direction, I think, to explore how these parallel efforts could join together and help us to actually solve the challenge for autonomous network in the future. So, ladies and gentlemen, thank you for your participation. Now is the time for lunch break. I would like to remind you that our afternoon session will start at 2 a.m. Beijing time, which is in 2 hours. Do join us in the upcoming thought-provoking presentations from NVIDIA, Rebellions, iFlyTech, Upstate Hong Kong, etc., and also Linux Foundation AI and Network and Data. 女士们、先生们，感谢您的参与与关注。我们上午的会议告一段落，现在是午休时间。下午呢，我们安排了来自英伟达、Rebellions、科大讯飞，还有 Linux 基金会专家的精彩分享。下午2点我们再见 ，See you later。